Roughly 9 out of 10 bends made on a modern press brake are air bends. The other two methods, bottoming and coining, can need several times the tonnage for the same part. Pick the wrong one and you either fight springback all day or destroy tooling. Here's the difference that actually matters. All three use the same basic setup: a punch above, a V-die below, a sheet between them. The only thing that changes is how far the ram travels and how much of the material you force to yield. That single difference drives tonnage, springback, tool wear, and repeatability. In air bending, the sheet only touches 3 points: the punch tip and the two die shoulders. It never reaches the bottom of the V. The angle is set purely by how deep the ram stops. Stop shallower, get a more open angle. Same tools, any angle you like. That flexibility is why it dominates. One punch and one die can produce a whole job list of angles under CNC control, with no tool changes. It also uses the least force because you are only bending the sheet, not reshaping it against the die walls. The cost is springback. Air bending leaves an elastic core in the middle of the material that pulls the angle back open when the punch lifts. On mild steel, that might be a degree or two. On high-strength steel or stainless, considerably more, and it changes with every coil of material. In air bending, the radius is not the punch radius. It is set by the die opening, roughly the opening divided by 6 for mild steel. Change to a wider die and the inside radius grows, whether your drawing said so or not. Bottoming goes further. The ram drives the sheet down until it conforms to the walls of the die, so the die angle, not the ram position, defines the bend. Springback drops sharply because the material is held against a hard reference. Expect on the order of 2 to 3 times the air bending force. That is why bottoming dies are usually ground a little acute, often 88 degrees for a 90-degree part. The die overbends slightly, the material relaxes into square, and you get consistent angles without chasing depth corrections. The trade is one die per angle. Coining is the extreme. The punch nose is pressed into the material hard enough to plastically deform it through the full thickness at the bend. So almost nothing elastic is left to spring back. It also needs by far the most force, commonly quoted at 5 to 10 times an air bend. That force goes somewhere. Coining thins the material at the bend, hammers the punch and die, and eats machine capacity fast. Run the tonnage before you try it. A job that air bends comfortably can exceed the machine's rating when coined, and the frame is what pays. So, air bend by default because it is flexible and cheap on force. Bottom it when you need tight, repeatable angles and the tonnage is there. Coin it only when the part genuinely demands a sharp, dead-accurate bend, and check the numbers first. Subscribe for more. Next, the 7 reasons your laser cut edge looks ugly.